All right, hello class. I hope you're all doing well. And this is just a quick walkthrough of the relationships between heat energy, mass, and temperature. You guys should have done this already for yourselves on task number 2. If you haven't done it, please go back before you continue with this video because I'll be revealing the relationships here. But I want you to take some time and see the relationships for yourself with the data that you've been given. So, you've been given 3 different quantities, Q, M, and T. They each represent heat energy, mass, and temperature, respectively. And then there's also this other letter there called C, right? So C, you guys should have seen the C. What is C? C stands for specific heat. And what is specific heat? Well, good question. Specific heat is the amount of heat required to raise the temperature of mass of a given substance by 1 degree. So, how much heat is required to raise something's temperature by 1 degree? It changes by different substance, right? So if we have a glass of water, this is going to have a different specific heat than if you have, let's say, a pan for cooking, okay? If you have a pan for cooking, this is going to have a different specific heat than, let's say, a brick, okay? So each one of these has a different specific heat, and it changes depending on the substance. So let's come back. If you notice, the C and all those stayed the same because we were using the same substance for every single example there. Now, if you look at what was happening between Q and M and T, one of them should have stayed constant through the whole time, and the other two would have changed. So, whenever we saw that Q was increasing, what happened to the mass? You should have seen that mass was also increasing. Okay, and if you looked at the temperature one, you should also have seen that temperature was also increasing. Now, quick note. We should have noticed that this is a change in temperature. It's not just temperature, right? We have a change. So, when Q increases, what happens to the change in temperature? It should also increase. What happens to the mass? It should also increase. Okay, let's go on to mass. When mass was increasing, what was happening with Q? Well, again, we saw it up there. Q should have been increasing. And if you look at the one with T, the change in temperature should have gone down. It should have decreased. So the change in temperature should have decreased. Now, let's sum it up with our change in temperature. Remember, this has to be change. It's not just temperature, it's a change. We should have noticed that when change in temperature increased, the Q, or heat energy, should have increased, and then our mass should have decreased. So, these are the relationships between Q, M, and delta T. But how the heck do we go from this to any sort of equation? All right, so this is where I want you to stop. If you haven't done it for yourself, try it, okay? Look at the relationships between these. How do you think this relates? You can write this down as a equation. Well, another way we can write these relationships is by using this little sign. I'm pretty sure you've seen it before. So Q is directly relational to delta T. Why is that? Because when Q increases, delta T increases too. Okay, let's look at mass. Mass is inversely proportional, so we're going to go 1 over our delta T. Because as this increases, this is going to decrease. Okay? And the last one is Q proportional to M. Okay? So, whenever you're showing the relationships between these, in this way, we can now write an equation. So, whenever it's directly proportional, it's the Q should be on opposite sides. Okay? So, they should be on opposite sides. So, Q should be opposite side of delta T, Q should be opposite side of M. When it's inversely proportional, that means that they're going to be on the same side of the equation. So if it's inversely, Q is on this side, which means T should be on this side, M should be on this side, and this tells us that they should be on the M side, on the same side too, because they're inversely proportional. So we have M and delta T. However, don't forget that we need our C as well. Our C has to be involved in this, and C in this case is a constant. So the way we can end up rewriting all of this, if we include our C, is Q equals MC delta T. That's the equation you should have gotten. Okay? So, This explains the relationships between what we observe in heat, temperature, and mass, and this constant, which remember is specific heat. Okay, so you're going to be doing some practice problems in task number 4 to just tie this up. But if you have any questions, please reach out or please go to one of the office hours. All right, so just to clarify, Q equals heat energy. So Q stands for heat energy. And this can be either lost or gained, because it's possible to have a negative Q. M is going to be our mass. It's going to measure in our grams. Okay, mass, grams. And then, or it could also be kilograms, just depends. And then C is our specific heat. And then delta T is our change in temperature. Okay, so relationships here. If you have any questions, please reach out, office hours. If not, go ahead to number 4 and practice using this equation. All right, good job, everyone. Take care.